Right. So we have two addresses in each packet. Now, our interest of today's class is why do we need two address? Why should I have two address? Now, if you take a human being, we have a name. We also have some unique identity today. We call it as Aadhaar number. The other countries call different name, but everyone in all the developed country, if you see, definitely there is going to be a number and a name. A number and a name. There may be many numbers, passport number, phone number for an individual, but very soon they are going to make only one number for everything. Maybe they will take your Aadhaar number and make it as your phone number. Your phone number, your Aadhaar number, your bank number, your all number will be same for one person. They won't give to others because Aadhaar number is unique. They want to give you that as a phone number so that you will remember, or the government will remember with one number who Prem is. They may do it in the future. So now what I'm trying to say is each packet in a network has got two identification, MAC address and IP address. We learned in previous class, switches only focus on MAC address to move the packet from one port to another port. It receives packet in one port and it forwards in another port based on what? MAC address. Switches, they don't focus on IP address. Only MAC address. Only MAC address it uses. No IP address. Now, if the destination MAC address is not there in switch, what switch will do? If the destination MAC address is not found in the switch, what will switch do? Right. It will forward to all active ports. Perfect. See, when the destination MAC address of the packet is not seen in the MAC table, switch is going to flood it. If the destination IP address is not seen in the routing table, what will router do? Ah, It cannot forward the packet. It will drop the packet. Instead, it will send a message saying unroutable. Destination to which the packet needs to go is unroutable. Anyway, what I'm trying to explain today is there are two addresses. Why do we need two addresses? Why not just one address? Why we need two addresses for a packet? Why? Is both needed? If switches only uses MAC address, is there any need for an IP address? If router only uses IP address, is there any need for MAC address? This is what we are trying to understand. I tell you, you need both the address. That's the main, that's the final answer that you are going to understand. We need both address. If anyone is missing, OSI layer encapsulation will fail. That's the very first point. Both addresses are needed. If one address is missing, first of all, the packet won't be valid. It won't be created as a packet. The PC will simply, it won't forward the packet. Why? The OSI layer needs IP address in layer 3 and it needs MAC address in layer 2. See, OSI, when it creates a packet, it needs IP address and MAC address. Otherwise, it cannot create a packet. Encapsulation will fail. This is main reason. This is the first reason why we need both address. Second reason, we need both the address because both are used in forwarding the packet. Both are used in forwarding the packet. How? Let's say I have a computer here, and the computer will be connecting to a switch if you have many computers, and the switch will be connecting to a router, and the router may be connecting to many other routers, and you have the final destination here. Final destination here. Now, understand this carefully because this is the first time you are learning this. When you have IP address 10.0.0.1 here, whoever connects to the switch, they also will have same network, 10 only. This may be 2 here. This is the ID for the computer. This is the one ID for this computer in this network. Even in this side now, this port on the router should also be 10 only. 10.0.0. I should not use 1 and 2 because it is already used. I'll say 3. Okay. Now, likewise, let's say I have 20.0.0.2, and this port here is 20.0.0.3. Now, is this enough for communication? No. Even in this link, for these two to talk, they need an address. So let us say 30 here. 30.0.0.1, 30.0.0.2. See, in each link, a router should have different network. You understand? So I should not say here 30.0.0.3. Why? Because it's different link on a router. Each link should be in different network. Let's say this one is 40.0.0.1 and here 40.0.0.2. Right. Now, all these ports will have a MAC address also. Let me write the MAC address. For this PC, let's say MAC address is AA. For this PC, it's BBB. Here CCC. Right, LLL, TTT. Okay. Assume this as MAC address. What is the size of MAC address? 48-bit. But here, just pretend this is 48-bit. I don't want to write the big 48-bit MAC address. It will take time. It's not needed. Assume that this is a MAC address. Now, A wants to, okay, I need to write the name of the computer. A, B, 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 only I have written. So let's say A computer name is A. For our conversation, I would like to call this as A. This is B, C, D. Now A wants to talk to B, let's take. A wants to talk to B. What is there in the middle? Switch or router? Do switch needs an IP address to communicate or only the MAC address? MAC address. But this computer needs both. Okay. See, even the switch needs only MAC address. In this computer, when it generates a packet in layer 3, it needs to put IP address 10.0.0.1, 10.0.0.2. And in layer 2, it will put MAC address AAA and what is the destination? BBB. 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 So if this PC needs to, generate the packet, it must put this address here. Otherwise, it cannot generate. OSI layer will not be complete if you don't put IP address. The switch do not process the IP address, but for this PC to generate the packet, it needs IP address because according to the standard, it should have layer 3 information. Secondly, this receiving switch, the receiving PC, also needs to know whether the packet belongs to me. For that, it will check the MAC address first. MAC address is matching. And then it will check its own IP address. Is it matching here? Yes. Only then it will process the packet. You understand? Sending PC also needs, receiving PC also needs. See, sending PC sends because OSI layer says I need layer 3. Receiving PC also checks for layer 3 according to OSI. But in the middle, the switch, they really do not know what IP address the PC belong to because they don't know or they don't need that layer 3 info. They don't even process layer 3. This simply, when the packet comes, this will check only layer 2, and if the MAC address is there, it will forward the packet. But when this PC receives the packet, it will check whether my MAC address and the packet's MAC address is same. Destination MAC address of the packet and my MAC address is same. Is it same? Yes. Next, it will remove this layer and see whether my IP address and the packet's IP address is same. Is it same? Yes. Only then it will process. Did you understand this? Now, how this PC know? How this computer A know the IP address of the computer? How this PC knows? Source it knows 10.0.0.1. How it knows the destination? How A knows the destination IP address? How A knows the destination IP address? It is based on what you ping. Have you pinged in the computer any time before? Okay. So ping is checking the connectivity by sending some packets. We call it as echo packets. Echo. E-C-H. Echo. Echo packet means what? I should hear the sound back. That is what echo, no? Have you heard echo anytime? Where? Very nice. Empty space in a well, in a well. If you go for swimming in the well, sometime if it is a deep well, you will hear the sound. So well is too wide open, not much. But if it is narrow, குறுகலான கணத்துக்குள்ள சவுண்ட் வரும், அகலமான கணத்துல வராது. So you know what is echo now. Now, if it sends an echo packet, if 10002 is available, it will reply. That's called echo reply. The reply will come. If 10002 is off, if this computer is off, the reply will not come. For this, using a protocol called ICMP, Internet Control Management Protocol, ICMP, Internet Control Management Protocol. Using a protocol ICMP, you can ping from here to here. What is ping? Sending echo packet. To say, hey, if you're there, reply me. அப்பா அங்க இருந்தீங்கன்னா எனக்கு கொஞ்சம் ரிப்ளை பண்ணுங்கப்பா அப்படின்னு சொல்லி அனுப்புறது தான் echo packet. For that echo packet, we use ICMP to generate the echo packet. ICMP is the protocol that generates the echo packet. We call this process as pinging. Even normal people don't know need of networking. Even non-networking people, professionals or non-networking people, they'll say, I'll ping you at 10 o'clock. Yeah, I'll call you at 10 o'clock. That's the meaning, right? I'll ping you at 10 o'clock. Have you heard someone saying that? I'll ping you at 10 o'clock. It means what? I'll give you a call. If you are available, echo me back, meaning reply me back. That's why they call this pinging. Anyway, ping, P-I-N-G. So when you ping, you will put the IP address of this computer only, not the MAC address. We don't use ping or for any communication. We don't use MAC address. We use only IP address. So when you say 10002, then the packet will know what destination to put. You understand? நீங்க பிங் பண்ற அட்ரஸ் தான் டெஸ்டினேஷன் அட்ரஸ். Your address is source address. The address to which you ping is the destination address. Now, source MAC address in data link layer will be the own MAC address. Own MAC address, AAA. Source MAC address is own, AAA. Then the destination MAC address, சரியா? Destination MAC address, don't know. See, destination IP address you know because you are pinging. How this computer know the other computer's MAC address? Not possible, right? How my computer knows the next computer which I bought yesterday? Not possible. IP address it knows because I am putting the IP address while pinging, but while pinging I don't put MAC address. And we don't use MAC address anytime to communicate. Then how will the MAC address be known? See, if you don't put MAC address here, the packet won't leave. Why? Encapsulation will fail. You agree? The OSI encapsulation will fail. புரிஞ்சுதா? அந்த ஓஎஸ்ஐக்கு ஐபி அட்ரஸ் இருக்கணும், மேக் அட்ரஸ் இருக்கணும். அப்பதான் இந்த பேக்கெட் நல்ல பேக்கெட் வெளியே அனுப்பும். If MAC address is missing, OSI will consider this as defective packet. It won't send. If MAC address is missing, it won't accept that as a complete industry standard, industry acceptable packet. It won't even send the packet out. Anyway, now the MAC addresses are known. The MAC addresses are known. Somehow You should know the MAC address. Only then the packet can be forwarded. How? How can I know the MAC address of a computer? Another computer. Using a protocol called, what is this? ARP. ARP is what you pronounce, that is right. But in industry, they don't call it as ERP, they call it as ARP. Address Resolution Protocol. Address Resolution Protocol. Address Resolution Protocol, ARP. Address Resolution Protocol, ARP. It uses ARP. It uses Address Resolution Protocol in order to know the MAC address of computer B. See, you know computer B's IP address, no? Because you are pinging. If you don't know how you will ping. This computer knows the destination IP address. With the IP address, it can learn the MAC address with the help of protocol ARP. You see, this computer, this computer will use ARP and send a broadcast packet to this address. Broadcast means what? F address. If all the 12 hexa digit is F, MAC address is what? MAC address is 12 digit. I told you it is 12 hexa bits. If it is binary, then it is 48 bit. When you write, why do you write in hexa? Because 48 bit is too lengthy. When you write in hexa, it becomes only 12 digit. Now, if all the 12 digit is F, it is not a valid MAC address. That MAC address is called as broadcast MAC address. Layer 2, broadcast MAC address. Layer 2, broadcast address. Layer 2 broadcast address will be like this. Twelve times F. Okay, let me show you the what is the CMD. Okay, type CMD, and then there's a table called ARP table. You see, ARP hyphen A. Yeah, when you put this, it is going to show the MAC addresses of the computers that you are communicating. In your house, you may be talking to a router now. Via router, only packet is coming to me. From your laptop, it will go to router. Do you know the IP address of router? Your router? Do you know IP address of your computer? Find and tell me. ARP hyphen A, when you type, you will see the gateway's MAC address. Not only gateway's MAC address, you will see many MAC address and many IP address. ARP, Address Resolution Protocol, ARP, space hyphen A, ARP space hyphen A. Now you see you locate your gateway address 192.168 whatever dot 1. Do you see a MAC address there? Ah, you okay? Physical address. And also you will see FFFFFFF. Do you see there? That is the layer 2 broadcast address. So we saw our computer knows the MAC address of your router. Your computer knows the MAC address of your router. My computer knows the MAC address of my router. But did you feed the MAC address? No. It learned through ARP. ARP. It's not ARC. This ARP. ARP. Address resolution. You see, I have written P protocol. Resolution. A address. Okay. ARP. With the help of ARP, it can discover MAC address. How? It will send this packet with all FFF. If it sends a broadcast packet, what the switch will do, it will flood it to everyone. You understand? If the destination address is FFFFF, if the destination MAC address is FFFFF 12 times, the receiving switch supposed to do what? Broadcast, because it's a broadcast address. Switch will simply forward it to every port. And now all the PCs will receive the packet, and this PC, when it receives this packet, it checks the MAC address FFFFF, which means this packet belongs to me also. Okay? If the packet has got BBB, it will accept my packet. If it see FFF, it will say, okay, for me also it belongs to, because F means for everyone. All the systems inside this LAN, whoever is connected to the switch will receive the packet. Everyone will open the packet because F means all. Let's see, in India, you cannot print a wedding invitation for all the employees in the office. So what they do is, they will put to all and they will stick it in a notice board. I don't know whether they do it or not. I have heard someone doing that. Only one wedding card. There is one notice board in the office, it seems. To all. Which means whoever is seeing the wedding card, they are invited. Likewise, if FFFF is the destination address, the switch will forward the packet to everyone. Now PCB receives the packet and checks, is it my packet? It's not my packet, but I can open it. Why? It is said to everyone who receives it. That's the meaning of FFFF. So it opens further and it will check whether the IP address is matching. This should match. Yes, it is matching. Then B understands it's my packet. Rest of the devices will not open further, but this PC will open further. Here it will see a payload. What is your IP? ARP is asking a question. What is your IP? We call this as what? ARP request or echo request. Okay, we call this as echo request. Now, as soon as we see the question, what is your IP? It immediately responds. Tell me what will be the source packet of the response packet. B is responding now to the question A was asking. A is asking what is your MAC address. Now B have to respond back. What will be the source IP? Correct. What will be the destination IP? Whoever sent it, 10.0.0, 10.0.0.1. Now what will be the source MAC address? It puts its own MAC address, BBB, and it delivers the packet to destination A. And inside it will have my MAC address is BBB. This is called ARP reply, echo reply. Okay. Now, not ICMP, echo, not echo, it's R reply. Hmm? Now, when this packet arrives, A understands that the MAC address of 10002, the MAC address of 10002 is BBB. And it learns in the ARP table. I showed you ARP table, right? What is the command to see the ARP table? A. That's it. That is how your computer learned the MAC address of your router. That's the MAC address of your router. You should keep it really safe because your router is connected to internet. If they know your IP address and the MAC address, they will easily attack you. If they know only the IP address, then also attack is possible, but not that easy. But when they know your MAC address, which is very unique, then problem. More easy. Okay, anyhow. Your PC now knows the destination MAC address. Packet now comes to the switch. Switch will check the MAC address BBB. It understands that it is connected here. Switch maintains the MAC table, no? Switch knows which port it is connected. It sends the packet here. Fine. Now, switch did not use the IP address. It was only using the MAC address. But the receiving PC, it will first check whether this MAC address is my MAC address. Yes, it is my MAC address. Secondly, it will check, after checking, it will remove this layer and then it will go to this layer and check whether this IP address is my IP address. Yes, it is my IP address. Only then it will respond to that echo, ICMP ping echo, no? It will respond. Fine. Now, when I ping, because I have MAC address, I can ping. Now, next what we are going to learn is, if A wants to ping C, if A wants to ping C, C is not in the same network. It is in different network. How it is going to ping and how this MAC address and IP address will help. Let's see. Now, what is the source IP address? It's the same IP address, 10.0.0.1. And now, what is the destination that you are trying to ping? It is 20.0.0. Complete it. 20.0.0.2. Yes or no? 20.0.0.2. Now, you see this one. Very nice. You know how the operating system is designed. If the source network and destination network is same, is it same now? But earlier it was same, no? When it is same, it will not use the gateway address. In your computer, you have gateway address 192.168.23.1 you said. You remember? .1. Your router's address is the gateway. If the source and destination is same network, if it is here, it is different. If it is same, it won't use the gateway. If it is different, the packet should first go to the router. Yes or no? It has to go to the router. So it will use the gateway address. What is the gateway's address? Here. Here, what is the gateway's address? Please answer. No? What is the gateway address here? In your computer, the gateway address is your router's address, 192.168.23.1. Here, what is the gateway address in this picture? For this computer A, what is the gateway address? Like I said, router address. 10003. இது உங்க லேப்டாப்னா, இது உங்க ரவுட்டர்னா, இந்த ரவுட்டர் அட்ரஸ் 192.168.23.1. அதுதான் இந்த அட்ரஸ் உங்க ரவுட்டர்ல. இந்த பக்கம் நீங்க இன்டர்நெட் கனெக்ட் பண்ணிருக்கிறீங்க, புரியுதா? அது வேற அட்ரஸ். உங்க ரவுட்டர்ல ரெண்டு அட்ரஸ் இருக்கும். ஒன்னு ரவுட்டரை குறிக்கிற அட்ரஸ், இன்னொன்னு வெளியே இருந்து வரவங்க இந்த ரவுட்டரை குறிக்கிற அட்ரஸ். ரெண்டு அட்ரஸ் இருக்கும். So what is the gateway of PCA? Computer A. What is the gateway of computer A? என்னங்க சார், gateway of PC na IP address of PC ன்னு கேட்கலையே. What is the gateway of this computer? இந்த கம்ப்யூட்டர் இருந்தாலும் சரி, இந்த கம்ப்யூட்டர் இருந்தாலும் சரி, ஒரே கேட்வே தான். இதுதான் கேட்வேனாலும் ரவுட்டர்னாலும் ஒண்ணுதான், புரியுதா? ஓகே. What is the gateway address of this computer A and B? 10.0.0 10.0.0. That is the gateway. Now, when will this gateway be used? If your source and destination network is different. In our case right now, it is different, no? So, in order to move the packet first from here to here, it needs to know the gateway. That is why we we configure gateway in our computer. See, for your computer, IP address is enough. Why it is given gateway? Because whenever you want to go to different network, the packet cannot be routed by PC. It needs to take the help from the router to route. So it has to send the packet to the router. For that, it needs to know the gateway address. For that only we have gateway address here. The reason why gateway is here, 192.168.1.1. The reason why you have gateway here is, see, my computer IP address is this. Why do I need gateway? So that whenever my computer want to talk to internet, which is different network, the packet will go to the router only, because I do not know the internet. Who knows my internet? Who knows the internet? My router only knows the internet. So I need to go to the router. That is why gateway is assigned to all our computers. Now the packet needs to go to where? Gateway. But if I put the gateway's address here, 10.0.0.3, the packet will go here and it will stop. It will not know that I need to go to 20.0.0.2. Your aim is not to go to 10.0.0.3. Your ultimate aim is to go to 20.0.0.2. So how can I put gateway address? You need to put only gateway MAC address. IP address should be 20.0.0.2 only. But your MAC address will be your gateway's MAC address, which is GGG. See, because your computer knows the gateway, it will use the ARP protocol and learn the MAC address, like what we saw between A and B. So it learns the MAC address, it puts the MAC address JJJ, and switch will move the packet in this direction. It goes here. The router will check for the IP address only, isn't it? It will check and it finds the 20 network is what the packet wants to go. It will forward this way. Likewise, this router will forward this way. and this router will at last send here, and switch will send here. So you see, it's the same R which learns the MAC address of the router and gives you. Just by using MAC address, packet was jumping from here to here. Did I put the router's IP address here? No. I just put the router's MAC address. Packet was jumping from here to router. And router will check the network. Do I know the network? Yes. In the routing table, router knows that 20 is in this direction. Okay. This router will also know 20 is in this direction. This router will also know 20 is in this direction. Okay. That's the job of router. Router will know the remote destinations network. Now, if there is no MAC address concept, then it is not possible for you to go from here to here. Why? You will have only IP address to put here. You will put the router's IP address and it will go here and stop. Because you have two address, MAC address and IP address, you put the MAC address to jump from one hop to another by keeping the destination unchanged till it reaches the destination computer. And the destination IP மாறவே மாறாது கடைசி போய் சேர்ற வரைக்கும். But to reach the destination, the MAC address will keep changing every hop. Means in here, if you capture the packet, இந்த இடத்துல பாக்கெட்டை பிடிச்சி பார்த்தீங்கன்னா, the source MAC address and destination MAC address will be like this, TTT FFF. You understand? Every hop, the MAC address will change, but the IP address of source and destination will be same. All right? Packet comes from here. When it goes to the first router, this was the source MAC address and this was the destination MAC address. When it go from this router to this router, IP address will be same. What will be the MAC address? Talivare. KKK LLL. So packet will jump from here to here. And after coming here, the IP address is same, but what will change? The source and destination MAC address, TTT FFF. Now, what will be the packet's destination MAC address when I receive here? It will be CCC. What will be the source MAC address? When I receive the packet here, what will be the source MAC address? Packet Ramji, Wardji. You accepted here as a K, you accepted here as T. Then why you say A here when you are receiving packets from here? So, in short, what I want to say is, if you don't have MAC address and IP address, this communication would have not been possible. Because you have MAC address, you are able to jump by keeping this address unchanged till it reaches the destination. இல்லையா? இந்த அட்ரஸை மாத்தாம கடைசி வரைக்கும் எங்க போகணுங்கிறத மாத்தாம வச்சுக்கிட்டே நம்ம ஒரு ரவுட்டரா ஜம்ப் பண்ண முடியுது. காரணம், ஜம்ப் பண்றதுக்கு மேக் அட்ரஸை யூஸ் பண்ணிக்கிறோம். பேக்கெட் ஃபைனலா எங்க போகணுன்றத தெரிஞ்சுக்கிறதுக்கு ஐபி அட்ரஸை யூஸ் பண்ணிக்கிறோம். இது ரெண்டும் இருந்தாதான் கம்யூனிகேஷன் நடக்கும். You need both. This is very, 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 very important topic. Many people know networking, but even though this is very simple, fundamental, they don't know this. இது ஒரு அடிப்படையா இருந்த ஒரு விஷயம். அவங்க கிட்ட கேட்டீங்கன்னா, ஏன்பா ரெண்டு அட்ரஸ் மேக் அட்ரஸும் இருக்குது, ஐபி அட்ரஸும் இருக்குது, ஒரு அட்ரஸ் போதாதா ஒரு டிவைஸ்க்கு அப்படின்னா, அது ஒன்றும் இல்லைப்பா, சுவிட்ச் வந்து மேக் அட்ரஸ் தான்ப்பா அதுக்கு புரியும், ரவுட்டர் வந்து ஐபி அட்ரஸ் தான் புரியும், அதனால ரெண்டும் வேணும்ன்றாங்க. நோ, தட் இஸ் நாட் த ஒன்லி ஆன்சர். See, if switch understands only one address, then they won't keep as a standard. We need both. இந்த சுவிட்சுக்காக நான் மேக் அட்ரஸ் வைக்கல, கம்யூனிகேஷனுக்கு வெறும் ஐபி அட்ரஸ் மட்டுமே போதும்னா சுவிட்சை தூக்கிடுவாங்க. சுவிட்சையும் வந்து ஐபி அட்ரஸ் புரிஞ்சுக்கிற மாதிரி டிசைன் பண்ணுவாங்க. The purpose of having MAC address is to jump from one device to another routing device, one routing device to another routing device. Whereas switch is to move the packet within the routing domain. I'll stop here.